In the lesson today, we're going to be taking verbal expressions and translating them into algebraic expressions. And so in this box right here, we have a whole bunch of words that have a meaning in mathematics. Some of the words represent addition, some are subtraction, some are multiplication, some are division. All right, and so I said to use your words into math sheet, which I'm going to give you. It's going to look something like this. Okay, and you can see that inside of each of these I have different words put in there. And we need to know when we see these words that they represent the specific operation. Okay, so use that words into math sheet to help you when we're translating. And there's one big translation that we need to be aware of, and it's this one right here. Okay, in the examples underneath, you're going to see a number quite a lot, all right? When they say a number, they're not telling you specifically what number they're talking about. So when they say a number, we're actually going to be using a variable to represent it, since we don't know the value of the number that they're talking about. Okay, so keep that in mind. All right, use your words into math sheet to help you with these words as you come across them in the problems below. And when they say a number, you're going to use a variable to represent that number. So let's take a look at some verbal expressions and see if we can translate them into algebraic expressions. Our first one says twice a number increased by 15. Okay, so the key words in this are twice and increased. And there's where they said a number. And remember, when they said a number, we're going to use a variable to represent it. So twice a number, okay? I would find twice under multiplication on my words into math sheet. Twice means to multiply by 2. So I'm going to take some number, which I'm going to use a variable to represent it, and multiply it by 2. So I'm going to start off by writing 2n as my algebraic expression. Twice a number. Take 2 and multiply it by some number, and then we're going to increase it by 15. Increased by would be found under addition, so I'm going to have to add 15. So the expression twice a number increased by 15 algebraically is 2n plus 15. In example 2, 7 more than twice a number. Okay, more than, and again twice are the key words here. We already saw up above twice a number meant to take 2 and multiply it by some number. 7 more than that means I'm going to have to add 7. More than is found underneath of addition. So I'm going to do 7 plus 2n in this example. 7 more than twice a number. All right, number 3, I'm going to put a star next to this one. This is an important one. 9 less than the product of 5 and a number. Okay, our keywords here are less than and product. All right, product I know means multiplication. So the product of 5 and a number, okay, I'm going to take 5 and multiply it by some variable because I don't know what the number is. If I want 9 less than that product, then I have to start with the product first. All right, less than means to subtract, but to be less than something, you're going to have to switch the order when you do the algebra. So I'm going to start with the product of 5 and a number, which is going to be 5 times n. And then to be 9 less than that product, I'm going to subtract 9. Okay, the subtraction has to come at the end in order to be less than that. All right, similarly, right here in number 4, take 5 from the product of 4 and a number. I have to take 5 from a product, okay, which means I have to start with the product, and then I'm going to take 5 from that, so I'm going to subtract 5 at the end. So for the product of 4 and a number, I'm going to do 4 times n, some number n. And then to take 5 from that, I'm just going to subtract 5. 4n minus 5 means take 5 from the product of 4 and a number. Okay? Again, similarly here, 12 subtracted from twice a number. All right, 12 is going to get subtracted from whatever twice the number is. So I have to start with twice a number, which I've seen before, which means 2 times n. And then I'm going to subtract 12 from that, which means I'm going to do minus 12. So with these 3 examples, all right, less than, take from, and subtract from, you have to switch around the order when you do the algebra. Okay, the words in the algebra are going to be switched around. Twice a number increased by 4 is 25. Twice a number, I've done that many times, 2n. Increased means to add 4. And then it says is. Is in this case means equals 25. And so we actually have an equation in this example. Twice the number increased by 4 is 25. Number 7 is another important one. 3 times the sum of a number and 8. 3 is going to multiply the entire sum of some number and 8. So if I find that sum, a number and 8, I'm going to add them together. A number plus 8, that's the sum of a number and 8. And now I want 3 times that sum. So I have to put the entire sum in parentheses and then multiply it by 3. So I would do a little distributive property here if I were actually trying to evaluate. 15 more than the product of a number and 9. 15 more than the product of a number and 9. So 15 more than means I'm going to do 15 plus, and then product means to multiply a number and 9. So 9 times some number n. 5 is decreased by twice the number. Okay, now this one I'm not going to switch around because I'm not subtracting 5 from twice the number. 5 is going to get decreased by, so I'm going to subtract it by twice a number. The quotient of 3 in a number decreased by 2. Now let's talk about this. Quotient means division, and in algebra, division looks like a fraction. So I'm going to write a fraction for my division of 3 and a number. So 3 goes in the numerator, some number goes in the denominator, and then I'm going to decrease it or subtract it by 2. Okay, and then number 11, again, I'll put a star next to this one. 7 less than the product of 6 and a number. Less than, I have to switch the order around when I do the algebra. So I'll start with the product of 6 and a number, 6n, and then 7 less than that, I'm going to subtract 7. In question 18, they tell us that we have saved $25 and we're going to save $4 more per week. So letter A asks us to find an expression to represent our total savings after 8 weeks. Okay, so I have already saved $25, so that's my starting point, $25. And then I'm going to save an additional $4 more per week. All right, so $4 more for 8 weeks means I'm going to have to do 4 times 8. And then once I know this value and I know my 25, I would have to add them together. So 25 plus 4 times 8 represents the total cost or the total amount of savings after 8 weeks. Write an expression for your total savings after 12 weeks. Well, again, I'm starting with $25 and then I'm going to add to it my savings after 12 more weeks. I'm saving $4 more each week for 12 weeks. So my expression looks similar. I've just changed my weeks from 8 weeks to 12 weeks. Write an expression for your total savings after n weeks. So after any number of weeks. Well, I'm starting with my $25, and then I'm going to add to that my additional savings, which is $4 per week, so times the value of n. Whatever the value of n is for the number of weeks, I multiplied that by 4, and then I add it to the $25 I've already saved. In example 19, Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. Write an expression that represents the total amount of money Marissa saved after any number of weeks. Okay, after any number of weeks. So they haven't told us specifically how many weeks, so I'm going to use a variable to represent that. She saved $25 already, so we're going to start with the $25. She's saving $10 each week. So I'm going to take $10 and multiply it by my number of weeks, which any number of weeks can be any number. So I'm going to multiply it by n, some variable. And then to figure out the amount that she has saved, I have to take these two and add them together. 25 plus 10 times n. B wants to know, will Marissa have enough money saved up after 11 weeks to buy that DVD player? So we're going to take this expression, 25 plus 10n, and we're going to replace n with 11 weeks. So we're going to do 25 plus 10 times 11. I need to multiply first, so I'm going to have 25 plus 10 times 11 is 110. And then if I add 110 with 125, I get 135. Well, the DVD player cost $150, so I can say no. Marissa will not have enough money. All right, she's going to have to keep saving if she wants to buy that DVD player. In our next example, we're told that Sue repairs televisions. She charges $30 for a diagnostic fee plus $24 per hour. Suppose a job takes 4 hours. Write an expression for the amount of money that Sue charges and then evaluate your expression. Okay, so Sue is going to charge $30 to diagnose what's wrong with the TV. Once she knows what's wrong with it, she's going to charge you $24 per hour it takes her to fix the TV. So if the job took 4 hours, let's figure out how much money we would have to pay. So we have to pay that $30 diagnostic fee just to figure out what's wrong with our TV. And then $24 per hour for 4 hours. So I'm going to do 24 times 4. And then I'm going to take these two values and I'm going to have to add them together to get my total cost. So I'm going to have to start with multiplication. 24 times 4, well, that's going to be 96. So I'm going to have 30 plus 96. And when I add 30 and 96, that gives me 126. So I can say that Sue charges $126 for a 4-hour repair. Okay, so you take the diagnostic fee, add on $24 per number of hours. In this case, it was 4 hours. Well, suppose the job took 8 hours. Write an expression for the amount that Sue charges and then evaluate it. So it's going to be very similar to this expression. The only difference is that instead of 4 hours, it's going to take 8 hours. So our expression is going to say 30 plus 24 times 8. The diagnostic fee, the hourly fee times the number of hours. Multiply first. 24 times 8 is going to be 192, so we're going to have 30 plus 192. Now if we add these together, we get 222. So we'll say that Sue charges $222 for an 8-hour repair. Okay, well, suppose a job takes 8 hours. Write an expression for the amount of money that Sue will charge you. Well, she's going to charge you $30 diagnostic fee plus $24 per hour times H. So this is the expression that you could use to figure out the amount charged for any number of hours. A website charges 80 cents to download a game and $12.50 for a membership fee. Write an expression that gives the total cost in dollars to download G games, and then find the cost of downloading 6 games. Okay, well, we can't download any games until we join the club, so we have to pay that $12.50 membership fee. And then it's going to be 80 cents per game G, so 80 cents times G. And then again, I'm going to have to add these totals together. So this is our expression, $12.50 plus 80 cents G. Now we want to get 6 games, so replace G with 6. $12.50 plus 80 cents times 6. And we're going to multiply first. 80 cents times 6, that's going to be $4.80, so it's $12.50 plus $4.80. And when you add these two values together, that gives you $17.30. So you will pay $17.30 to join and download 6 games. An MP3 player costs $70, and then song downloads are 90 cents each. Write an expression for the cost of the MP3 player and X songs, and then find the cost of 20 songs getting downloaded. So we have to buy our MP3 player for $70, and then each song is 90 cents. So it's going to be 90 cents times the number of songs, which is going to be X in this case, and then we'll add them together. So there's our expression. Now substitute in the value of the songs, which is 20. 70 plus 90 cents times 20. Okay, that's going to be 18 plus 70, which is going to be 88. So it's $88.